8085 microprocessor. We are taking the MCQ, multiple choice question, objective question on it. 8085 microprocessor unit, MPU, or microprocessing unit, is, now this 8085 is a 8-bit MPU. So why it is 8-bit? Now you see, it has 8-bit internal data bus. Whichever processor you talk about, the size or the bits of the data bus will decide that the MPU is of which size, which bit size. Okay, so 8085, 8 bits. So it is a 8-bit microprocessor because the data width is 8 bits. Since the address width is 16-bit and this 8-bit is multiplexed, actually it is 16-bit address bus and the 8-bit is the data bus, okay, which are multiplexed. So if you talk about 8086, it is a 16-bit microprocessor, 16-bit microprocessor. So data width is 16 bits in 8086 and the address width is 20 bits. Okay, let me tell you again, 8086 16 bits, address width is 20 bits. The 8085 microprocessor has, so we just came to know that 8085 is having 8-bit data bus and 16-bit address bus. So the address bus is of 16-bit and in this 16-bit the 8-bit is used as the data bus. That is, there is no different data bus or address bus. They are not different, they are one. So 8-bit data bus, 16-bit is the address bus. So in 8085 microprocessor, 8 data lines are provided to transfer the data, that is the database. And these 8 lines are multiplexed, so they serve a dual purpose, two purpose of being used either for addressing or it can be used for data transfer also, right? So these 8 lines serves as the lower 8-bit of the 18-bit address. So let me tell you here, AD0, it starts from here. And if you start from 0, it goes up to 15. That counts to 16. So AD0 till AD7, these are 8 bits. And these 8 bits are for data bus. And AD0 till A15, total in all the 16 bits, is for the address bus. Okay, because there is an ALE, we'll talk about ALE in a short while, latch, and that decides whether the data or this address bus will be used. So it is a 16-bit address bus, 8-bit data bus. What is the maximum addressing capability of Intel 8085? Now 8085 is a 8-bit microprocessor and it has 16-bit address bus, 8-bit data bus, 16-bit address bus. So there is always a confusion that what is the maximum addressing capability. Maximum addressing capability comes from the address bus size, not the data bus size. Okay, so 64 KB has come from 2 to the power 16. Okay, in 8085, as I said, it is a 8-bit microprocessor. So you will just say, oh, 8-bit microprocessor, so 2 to the power 8, that is 256. No, it is actually 2 to the power 16. And when you take 2 to the power 16, 2 to the power 6 is 64. And 2 to the power 10 is 1024. You can count it as 1000 also. So that comes to be 64,000. So you can call it as 64 KB, kilobyte. But here is a catch. In this, whenever we talk about memory, 1000 is not equal to 1024 because this goes 1 KB is 1024 bytes. But still we call it as 64 kilobytes, and here kilo is 1024, not 1000, right? So 8085 is a 8-bit microprocessor and it can have access up to 64 KB of memory. The main purpose of accumulator register of 8085. The name itself suggests that it is a register and it accumulates. Everything happens here. So this is a data storage and this is a temporary data storage used by the microprocessor. Temporary data storage. Okay, so we have in 8085 we have registers that are used to store data. So what is a register? Basically, flip-flop is for 1 bit. So when we have the combination of various flip-flops, you might have heard about JK flip-flop, SR flip-flop, D flip-flop, like that. So when you combine the flip-flop, it will give result to a register. And register is the addressable memory. Okay. So this, it is a 8-bit, right? Accumulator, it is an 8-bit register that contains 8 flip-flop. It can store a maximum of 8 bits of data. So the importance of this accumulator is that in most of the 8-bit arithmetic and logical operation, whichever arithmetic logical operation is happening, the microprocessor will always take the first 8-bit number from the accumulator. Okay. So in 8085 we have accumulator. Along with this we also have general purpose register. So B, C, D, E, H, L. These are 6 8-bit register. Each register contains 8 flip-flops. That is why it is a 8-bit register. Each register can store a maximum of 8 bits. That is 1 byte of data. And for storing data greater than 8 bits, these registers are used in pairs. So B, C, D, E, H, L, like this. So B is 8-bit, C combined. C is also 8-bit, it combines, and then 16-bit is used. So each register pair can store a maximum of 16 bits of data, that is 2 bytes of data, right? These are general purpose registers. There are certain temporary registers also. 3 8-bit registers, W, X, Z. Each register can store a maximum of 8 bit, and these registers cannot be used by the programmer. It cannot be accessed by the programmer. These registers can be used only by the microprocessor. In order to execute the operation, that is, the microprocessor will use these registers for the temporary storage of data. The status flag that is available in microprocessor 8085 but not available in microcontroller 8051. Now this is a very specific question with respect to one microprocessor and one microcontroller. So if you are able to understand the different flags, the status flag is whenever something is changing, the flag shows whether it is enabled or disabled. That is, for example, if a 100-page document is there, you want to show it to somebody, your officer, then you will put some flags, and those flags will determine the officer will have to open that these 3 are the flagged papers or part, and they have to read it. So flag can be, different flag can be either 0 or 1. So we say that it is set or not set. In flag register, this is an 8-bit flag register out of which 5 bits are used, like this. So 5 bits are used. D0 is a carry flag. So this D2 is a parity flag. This is set when the result have all even numbers of ones. Carry flag, as I just said, D0 is set when there is a carry generated by any of the operation or process. Then we have the D4 auxiliary carry flag, and this becomes 1 when there is a carry out of lower nibble, that is the 4 bits or lower 4 bits of the operation. Then comes the auxiliary carry flag. D5 is not D1, D3, D5. Now we have D6. This is 0 flag. This is set when the result of the operation becomes 0. All are zeros, then the 0 flags comes. Sign flag. This sign flag is set when the result of the operation is negative. Okay. And there are certain, different, depends on the microcontroller and microprocessor. For example, 0 flag is present in 8085, but it is not in 8051. There are certain flags which are in 8051 which may not be present in 8085 or 8086. But here the answer is a 0 flag. The highest priority interrupt in 8085 is, see if you are in a meeting, very important meeting with someone or some people, and some person came and he says, sir, I have to talk to you, it's very important. Or somebody comes to you, says, sir, I have to tell you something. There are two things, the two ways you can respond. You say, no, wait for some time and I'll talk to you. Or you say, oh, okay, tell me, come on. If it is important, just let me know. So the highest priority, that is, you need to listen to what the other person has to say before carrying on the meeting. That is the trap. The trap is the highest priority interrupt. Okay. So there are software interrupts, there are hardware interrupts, and the priority of interrupts, the top one is trap. Then comes this is a non-maskable. That is, the person will come, you cannot deny him. You have to address him, then you can continue your work or your meeting. And in terms of microprocessor has to, it cannot ignore this trap. Then comes RST 7.5, 6.5, 5.5 and INTR. So the answer here is trap. Which of the following interrupts is non-maskable in 8085 microprocessor? Non-maskable, again, the answer is trap. There are two types of interrupts, non-maskable or maskable. Non-maskable means you need to address that trap first. Or say, if the microprocessor can avoid, that are called maskable. The trap has the highest priority, then comes RST 7.5, 6.5, 5.5 and INTR. So let me tell you again, there are maskable interrupts and non-maskable interrupts. Maskable interrupts are those which can be disabled or it can be ignored by the microprocessor. Okay, these interrupts can either be edge triggered or level triggered, so they can be disabled. INTR, RST 7.5, 6.5, 5.5. These are maskable interrupts in 8085 microprocessor. When it comes to non-maskable interrupts, they are those interrupts which cannot be disabled or ignored by the microprocessor. The trap is a non-maskable interrupt. It consists of both level as well as edge triggering and is used for certain very critical things like power failure condition. In this condition, power failure, the microprocessor has to respond. Microprocessor has to do something else. Which stack is used in 8085 microprocessors? Stack, you can understand it by, you go to a party and there are stack of plates, one over the other. Okay, these are crockery or plates. So when you put a plate over one, you cannot take the below one before taking the top one. So this is called stack. This formation is called stack. In programming also, we implement this last in, first out. What is last in? The last in, that is the plate which is being put last, has to be taken out first. Last in, first out. So which stack is used in 8085 microprocessor? LIFO, last in, first out. Okay. So let me tell you more about this, because stack is very important when it comes to any of the microprocessor or the programming as well. So the stack pointer is an area of in the random access memory, read-write memory, and in which the temporary transformation is stored on last in first out basis, RAM. So once it is this is the temporary information place. Once you initialize, that is, an address is assigned in the RAM area to the first stack entry position, for example here 2099, and then it progressively decreases. Please remember, when it goes up, it decreases. So the stack pointer register holds the address of the last byte written onto the stack, and this is also called the top of the stack, or you can call it as a stack top. So the stack pointer register holds this address. So the stack pointer can be incremented, decremented depending upon the push and pop condition. Push is pushing the data on top of the stack, and pop means taking out or removing from the top of the stack. Okay, this is push and pop, and stack pointer is all about having the address of that. What is the length of stack pointer? Stack pointer length. So we are talking about 8085. It is of 16-bit. So let me analyze it first. See, we have B, C, D, E, H, L. These are general purpose register where the data is stored. And these are, this B and C, all these are 8 bits, but when you combine them, they work in pair. BC is 16-bit, DE is 16-bit, like this. HL is 16-bit. So in order to handle it, we have stack pointer and program counter. So stack pointer is 16-bit. So the stack pointer in 8085 microprocessor is a 16-bit register that stores the address of the top of the stack memory. The value of the stack pointer is decremented by 2 in the push operation, and it will be incremented by 2 in the pop operation. For example, these stack of plates. So the top plate, the address is actually the stack pointer address. So there are two operations possible. One is the pushing something data on top of the stack, that is pushing, and then taking out or removing the top item of the stack, that is the pop operation. The program counter is a microprocessor in a microprocessor. So this question we are going to take in the next discussion. Then thank you so much. Take care of yourself.